Hello and welcome to another video. In this video we're going to be working on path crossing. And in the problem, given a path where you have these directions north, south, east, west, representing moving one unit north, south, east, west, you start at the origin 0, 0, and you want to see where these directions take you, and if you ever go to the same point twice, then you want to return yes. Otherwise, you want to return false. So for this first example, you go north 1, east and south, and then you're done, so you don't ever cross where you started. And in the second example, you have north, east, south, west, west, so north, east, south, west, and then this basically makes you cross, and you want to return true. So this problem is pretty straightforward. Let's actually just draw like a graph here, and let's just have some points. And then with these points, we can easily figure out if we cross our points. So let's just say we have like north, east, south, north, north, south, south, west, or something. Essentially, what we're going to record actually is the coordinates of our point. So we're going to have an XY graph here, like this. And we're simply just going to record where we were at and where we visited. So in the beginning, we're gonna change this into points. So what we're going to do is we're going to start with 0, 0. And then we're basically just going to write where each one of these points takes us. And we can represent that on the graph, but we don't really need the graph. So let's say we start at 0, 0. So let's actually do it another color, like here. And then we can first draw it with a graph and then just draw the actual places. So north is up 1, then east is right, then south is down. So let's connect all these as well. So we go like this. Then we go north again. So we visited our point right here, right? When we go south and then north, we visited our point. So this should return true. So let's actually look at this from looking at points. So as we start at 0, 0, and let's actually copy all of this down here. And let's walk through like what these points would be. So when we go north, we go up 1. So on the y-axis, we would go up 1. So we'd say 1. Then we go east. So east means our x value goes up 1. So we would say 1, 1 here. And then south, our y value goes down 1. So it'd be 1, 0. And then north, like I said, this is where we go to the same point twice. So we would go up 1, so we'd go 1, 1, and we would intersect. And essentially, we can just keep track of all points we visit and store them in a set, right? And then once we are at a point, we can just check like, have we been here before? And then once we get to this point, we can be like, oh yeah, we were here before. So that means that there's an intersection. And the way we're going to store this is we're actually going to make a hash map, and I'll show you in the code, where each one of these directions will represent some change in x and y. And I think this is kind of a good format to do in a lot of problems where you're given some string and you want to actually turn it into numbers that are more usable. That's essentially all we need to do is we just go through this, we keep track of where we're at, and we just check in our set, have we been here before? And that's pretty much all we need to do. So we can code it up. So what we're going to do is we are going to have this like storing from characters to locations. So we'll say path or something. So if we go north, that means that like we're going to have an array of the x value change and the y value change. So north means the x stays the same and we go up 1. So the y value would increase by 1. Then south is the x stays the same and we go down 1. So y value decreases by 1. East, x goes to the right 1, so x increases by 1 and y value stays the same. And west, the x value goes left 1, so negative 1, and the y value stays the same. And that's pretty much all our coordinates. And now we can use this to, like, whatever point we're at. Let's say we're at 5, 6, and we go east. We can just say, like, okay, well, let's add 1 to the 5, and let's keep the 6 the same. So we can just take these two things and add it to our x and y to figure out our new point. So now we're going to have a visited set. And we're going to start with, we're going to add to it the tuple of 0, 0, because that's where we start. And in Python, you can just add tuples to your visited set. If you were doing another language that doesn't let you add tuples, you can just make a key of a string, and that would work as well. Because like you can't add types that can change value, so you can't add like an array. So what you would do is you would just take your x value, maybe put like a comma in here, and make this a string, x comma y or something. You make that whole thing a string, and then that can be your key that you add into your visited set, and you keep checking for it. Okay. So now we basically have to go through all of our points. So we'll say for character in path. Let's see what our new point would be. We also want to keep track of where we are in the x and the y. So we'll say x equals 0, y equals 0. That's where we currently are. And now for every character, we'll just say x plus equals. Oh, actually, we don't want to call this path. We want to call this something else. Maybe call this like directions or something, or dirs. So x plus equals dirs of character, and this is going to be at index 0, right? So this is the x value change, and then the second one's the y value change. So we'll say y plus equals dirs character at value 1. Now that we have this like xy coordinate, we just simply have to check, have we been here before? So if xy visited, let's return true, because we're supposed to return true if we've been here before. And then otherwise, we'll add it in. So visited.add xy. And finally, at the very end, return false, meaning we haven't been to, we went through the whole thing and we never went to the same point multiple times. So we can submit. And there we go. So let's talk about the time and space for this one. So the nice thing is also this doesn't really cost us anything because there's only 4 directions. This is constant space. But yeah, essentially we're going through every character. We're changing the x and y value. So that's O of n. We do have to have this set. So even though we did make this set can actually have, like assuming we went through all of our directions, worst case scenario is going to be O of n, right? Because every single direction might be unique. So, and you can only have as many unique directions or as many unique locations as characters in the path, right? For every single character, we might get a new location or might get a repeat. So this is O of n. And yeah, I think that's going to be all for this one. So another easy problem down the drain. And if you did like this one, then please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.